let's learn how to solve these two integrals. These are improper integrals of type 1, which means that one or both of their limits of integration involve infinity or minus infinity. So first of all, let's try to understand what part A is saying. We're trying to find the integral of 1 over x squared, which is equivalent to the area under the curve of 1 over x squared from x is 1 to x is infinity. So this highlighted area. Is this going to be finite? Is this going to be equal to some number, or is this going to be infinite? We're going to find out. So in order to solve an integral that has an infinity in it, we're going to introduce limit. We're going to put a letter, so let's say b, approaches infinity, and then where the infinity was, we're going to be putting the letter b. So this is the same thing as saying integral from 1 to infinity, but now we just have this letter b inside. And now we can integrate and we can substitute the 1 in b. So to integrate 1 over x squared, we're just going to change it to x to the power minus 2. Now we're going to integrate, add 1 to the power, divide by the new power, and I'm just going to rewrite it as minus 1 over x before I substitute the b and the 1. So now we're going to substitute the upper limit, so b. So we're going to get minus 1 over b. And then I'm going to substitute the 1, so we're going to get minus 1 over 1, so plus 1 over 1. And that just means minus 1 over b plus 1. Now we're going to see what's going to happen when I substitute the infinity inside minus 1 over b. So I'm going to get minus 1 over infinity. Now what happens in general if I have 1 over infinity? 1 over a really large number is just equal to 0. So I'm just going to have minus 0, which is just 0. So we're just going to be left with the limit as b approaches infinity of the constant 1, which is obviously going to be the constant 1. So that means that the area under the curve is equal to 1. So even though the area looked like it was going to be an infinite area, it's not. It was actually equal to 1, and it's convergent. Let's have a look at the second integral. It's very similar, but instead of x squared in the denominator, we're just going to have x. Let's see what's going to happen here. Again, if you want to, you don't have to draw the graph, but if you just want to have an idea of what the graph looks like, 1 over x, we're looking at the area from 1 to infinity. It looks very similar to the last one, but the answer is going to be very different. So we're going to solve it the exact same way we did. We want to use limits. So instead of infinity for the upper limit, we're going to put the letter b, and we're going to do limit as b approaches infinity. Now we know the integral of 1 over x, that's just ln absolute value of x. And we're going to go from x is 1 to x is b. And now we're just going to substitute. So we're going to put ln of b minus ln of 1. And we know that ln of 1 is just equal to 0. And for ln of b, as b approaches infinity, it means we're trying to find out what is ln of infinity. Let's have a look at the graph of ln x. We know the graph looks like this. So when x is approaching infinity, ln of infinity is just going to be infinity because the graph keeps going up. So the y value is infinity. And we're just going to get infinity minus 0, which is just infinity, which means that this integral does not converge. This integral diverges. Whenever it's not equal to a finite number, we use the word divergent.